Welcome. In this video, MATLAB and Simulink in Advanced Driver Assistance Systems, also known as ADAS. ADAS features such as adaptive cruise control, lane keeping assist, automatic emergency braking, traffic sign recognition, and parking assist require advanced modeling and validation. MATLAB and Simulink provide a unified environment for multi-domain modeling, rapid prototyping, algorithm design, and compliance with industry standards like ISO 26262 and AUTOSAR. They allow engineers to model sensors, develop algorithms, simulate interactions, and auto-generate production-ready ECU code. First, sensor modeling and fusion. Radar, LiDAR, and camera models can be created using Simulink's Sensor Fusion Toolbox. These models simulate object detection for distance, velocity, and classification. Fusion algorithms such as Kalman filters and probability hypothesis density filters are developed in MATLAB. For example, in automatic emergency braking, Simulink simulates a radar detecting a vehicle ahead. MATLAB calculates the time to collision, while camera fusion reduces false positives, such as mistaking a signboard for a car. Second, perception algorithm development. The MATLAB Computer Vision Toolbox supports lane detection, traffic sign recognition, and pedestrian detection. Deep learning models trained using CNNs are integrated into Simulink for real-time testing. For instance, in lane keeping assist, MATLAB detects lane boundaries using techniques like edge detection, Hauff transforms, or deep learning. Simulink then integrates these into a closed-loop controller for testing in a virtual road environment, reducing the need for physical trials. Third, decision-making logic. State flow within Simulink is used to design supervisory logic and finite state machines. For example, in adaptive cruise control, state flow determines whether the car should accelerate, maintain speed, or brake, depending on distance and velocity. MATLAB helps fine-tune control parameters such as PID gains for smooth driving. Fourth, vehicle dynamics simulation. The SimScape Vehicle Dynamics Toolbox models both longitudinal and lateral dynamics. It integrates with perception and control algorithms for system-level simulation. For example, in automatic emergency braking, Simulink computes braking torque, which is applied to the dynamics model. MATLAB then analyzes stopping distance, deceleration curves, and driver comfort metrics. Fifth, testing and validation. ADAS systems can be validated through multiple stages. Model-in-the-loop testing in MATLAB and Simulink, software-in-the-loop with generated C code, processor-in-the-loop on an actual ECU processor, and hardware-in-the-loop with real sensor connections. For example, in parking assist, simulated ultrasonic sensors detect obstacles, and controller actions like steering and braking are validated in HIL systems, reducing dependency on real vehicle testing. Finally, code generation and deployment. Embedded Coder automatically generates MISRA-compliant, optimized C code from Simulink models. This code supports AUTOSAR workflows and can be directly integrated into automotive ECUs. For instance, in lane keeping assist, the steering correction logic designed in Simulink is converted into ECU-ready code with minimal manual rewriting. This slide maps ADAS features with their respective MATLAB and Simulink roles. Adaptive cruise control. MATLAB develops car-following algorithms and optimizes PID gains, while Simulink simulates radar input and tests vehicle response. Lane keeping assist. MATLAB detects lane boundaries using the Computer Vision Toolbox, and Simulink integrates this with steering dynamics for closed-loop testing. Automatic emergency braking. MATLAB computes time to collision and classifies objects, while Simulink applies braking commands in vehicle models and validates through hardware-in-the-loop testing. Traffic sign recognition. MATLAB trains CNN models for sign recognition, and Simulink integrates perception into the driving decision framework. Parking assist. MATLAB pre-processes sensor data, while Simulink controls steering and simulates vehicle kinematics in tight environments. Thanks for watching. Interested in learning more about ADAS? We offer a course called Fundamentals of ADAS that covers 26 modules and 127 video lessons. Lifetime access. You'll learn at your own pace and get certified when you finish. Visit sarangatutorials.com to join today and take your first step toward becoming an ADAS professional. This course is designed and developed by Palam Vamshi, an alumnus of RIT Madras and a leading authority on automotive technology. Subscribe for more insights. Feel free to check out the course links in the description below. See you next time and drive safe.